All right. After an entire Algebra 1 curriculum, we're finally here. The goal for today is putting all your factoring skills together. So basically you've got ax squared plus bx plus c is equal to 0, where a, b, and c are going to be numbers. So you're trying to figure out the x values that make the y output equal to 0. Find all the x values that satisfy ax squared plus bx plus c is equal to 0. So what I like to do is right now, just take a deep breath. I know it's going to be overwhelming, but you've got this. You're very strong. We've been doing this all year. We've been focusing on quadratics for like a solid 2 months. So the goal is to satisfy the x values that incorporate the zero product principle, make the output equal to 0. So I'm going to give you a list of hints. Take a deep breath, absorb these one by one. There's 5 hints in total, 4 we're going to cover today. So the first hint, you should always be looking to factor out a GCF if you can. So you should always be asking yourself, can I divide something from all the terms and still get whole numbers? Make the problem easier to digest. I like smaller numbers. I'm not a big fan of huge numbers, especially if I can divide out a 2 or divide out a 3 or divide out a 10 or something like that. I love it. I love to make it smaller. Hint number 2. Okay, so when you've got a is equal to 1, so remember the goal is to figure out when ax squared plus bx plus c is equal to 0. Well, if a is equal to 1, then that's practically saying x squared plus bx plus c. So if you want to factor x squared plus bx plus c, you're figuring out what multiplies to c and adds to b, and then you use that combination to break it up into the binomials. So I'm a huge fan when a is equal to 1. That means less work for me. Everybody say it with me. Less work for me. I'm a big fan of less work for me. And then I can use the zero product principle. And then I hit that table and I break my knuckles. So then hint number 3, well, what if it's unfortunate that a is not equal to 1? You get ax squared plus bx plus c. Even though it's time consuming, you know what to do. Instead of figuring out what multiplies to c and adds to b, you're figuring out what multiplies to ac and adds to b. But you're not done, because you use that winning team to split the middle term, and then once you've done the ac adds to b split the middle term part, you put the pieces into the rectangle and factor out piece by piece. And there you go. Okay? So just to recap so far, try to divide something from all the terms if you can. If a is equal to 1, celebrate, because that means less work for me. If a is not equal to 1, that means more work for you, but it's not that bad. All right, hint number 4. So don't think I forgot about what happens if you have the difference of 2 squares. In other words, a squared minus b squared. Well, a squared minus b squared can be factored into conjugates. Everybody straighten the tie. I know you're wearing a t-shirt right now. Straighten the tie. I said straighten the tie. Straighten the tie. There we go. Now it's much better. Conjugates. So you factor them into conjugates. A squared minus b squared is equal to a plus b times a minus b. Or if you look at it like this, let's say you've got something like x squared minus 16. The square root of x squared is x. The square root of 16 is 4. So x squared minus 16, it might help to actually write this down. So for example, x squared minus 16 can be broken up into x plus 4, x minus 4. Okay? There we go. And hint number 5, it's blank. I wonder why it's blank. Oh, because at the end of the day, I'm going to put what hint number 5 is, but we're going to talk about that in the next video. Cliffhanger. Cliffhanger, like the end of a really, really gripping episode. Number 1. So this time, let's ease into this. Find the solution set for x squared plus 12x plus 35 is equal to 0. So take a deep breath. Can I divide something out from all 3 of these terms? Well, no, but a is equal to 1, right? There's nothing in front of x squared. I go a is equal to 1, just celebrate. Ooh, less work for me. Less work for me. So if you look back at your hints, if A is equal to 1, you just figure out what multiplies to C and adds to B, and then break that up. Okay, so in this case, what two numbers multiply to positive 35 and add to positive 12? I'm just going to kill time by saying A is equal to 1. Woo! I don't got to work. I love it when I don't got to work so hard. So if A is equal to 1, I'm trying to figure out what multiplies to C and adds to B. I'm going to have you guys pause the video. Do this on your own, because I'm going to give the combination in 5, 4, 3, 2, 1. Okay, so what two numbers multiply to 35 and add to 12? That answer is positive 5, positive 7, because 5 times 7 is 35. 5 plus 7 is 12. And because A is equal to 1, woo, I go right into the winning team. X plus 5, x plus 7 is equal to 0. Oh, I've got a multiplication problem. I love a multiplication problem, especially when the output is equal to 0, because then that means I can use the zero product principle, and I hit my fist on the pen. That hurt. So I'm going to split this into two separate equations because of the zero product principle. So now I've got x plus 5 is equal to 0, or x plus 7 is equal to 0. I'm a big fan. So let's start off with the right side, just because. So if I want to solve for x, subtract 7 from both sides, and x is equal to negative 7, that's one of the solutions. Okay, let's go to the other side now. X plus 5 is equal to 0. Subtract 5 from both sides, and x is equal to negative 5. Right? And that's how you do it. When A is equal to 1, woo, I don't have to work so hard, because it's just split. It's just figure out the winning team, split it into two binomials, zero product principle, solve for x on both. All right, number 2. X squared plus 5x minus 14 is equal to 0. Okay. Can I divide something from all the terms? No. Okay. Is A equal to 1? Yes. A is equal to 1. Everybody, woo. A equals 1. You can put woo. I don't really care. Woo. I don't want to work. I like it when I don't have to work so hard. So in this case, C is negative 14. So I'm going to multiply to C, negative 14, and add to B, which is positive 5. X squared plus 5x minus 14 is equal to 0. What two numbers multiply to negative 14 and add to 5? Pause the video, otherwise I'm giving the answer in 3, 2, 1. Well, that combination needs to be a positive times a negative, right? Because it has to multiply to negative 14. And if it adds to positive 5, that tells me that the positive has to be stronger. So it would be negative 2, positive 7. Negative 2 times 7 is negative 14. Negative 2 plus 7 is positive 5. You could have also written this as positive 7 times negative 2. It means the same thing. So without further ado, this is the binomial x minus 2, x plus 7 is equal to 0. Zero product principle. I've got a multiplication problem and the output is 0. I'm going to split this into two cases. Either x minus 2 equals 0, or x plus 7 is equal to 0. So let's start with the left side. X minus 2 equals 0. Let's solve for x. Well, I'm going to add 2 on both sides. X is equal to positive 2 is one of the solutions in the solution set. Are we done? No, don't yell at me. We need to solve for the other value of x. X plus 7 is equal to 0. That's another value that's going to make this output equal to 0. So if we subtract 7 from both sides, that leaves me with x is equal to negative 7. So the two solutions in this quadratic trinomial are x equals positive 2 or x equals negative 7. All right, moving on to problem number 3 now. 2x squared plus 22x plus 48 is equal to 0. Find the solution set. Find all the values of x that make this whole thing explode, become an output of 0. First things first, can I divide something from all three of these terms? It appears so. I can divide all three of these terms by 2, which, at first I was a little bit anxious because the a was equal to 2. Now that I factor out the 2, 2 times x squared is 2x squared. 2 times what is 22x? Positive 11x. And then 2 times what is positive 48? Positive 24 is equal to 0. Now, I don't really care about this 2 anymore. It just doesn't exist. Now, is a equal to 1 in that quadratic trinomial? Yes. I'm really happy that this a is just a secret 1. A equals 1. I'm going to go woo. I love it when a is equal to 1. I don't want to work so hard. So now that my b is 11 and my c is 24, my a is 1, thank goodness, I'm going to figure out the winning team. Two numbers that multiply to positive 24 and add to positive 11. Pause the video to do this on your own in 5, 4, 3, 2, 1. Okay, so the winning team, it has to be two numbers that multiply to positive, add to positive. That has to be a positive, positive. Two numbers that multiply to 24 and add to 11, without further ado, is 8 times 3. You could have done 3 times 8, but I'm just being it a little bit different. 8 times 3 is 24. 8 plus 3 is 11. And because a is equal to 1, woo, that means I can factor this into x plus 8, x plus 3 equals 0. And we factor out the 2 just to be mathematically consistent. But in reality, you don't really need it because we care about x plus 8 and x plus 3 equals 0. So now I'm going to break this up using the zero product principle. Big or. So now I've got x plus 3 equals 0, or x plus 8 equals 0. So now let's take a look at the left side. X plus 8 is equal to 0. Solve for x. I'm going to subtract 8 from both sides. So that leaves me with x is equal to negative 8. X plus 3 is equal to 0. We're going to subtract 3 from both sides. Or x is equal to negative 3. All right. Number 4. 5x squared minus 15x minus 90 is equal to 0. Find the solution set. Well, first things first, can I factor something out from all the terms? 5, 15, and 90. Yeah, in fact, I can factor out a 5. 5 times what is 5x squared? Just 1x squared. Hey, a is equal to 1. Woo, I forgot to woo. Don't forget to woo. A is equal to 1. I don't want to work. Woo. So 5 times x squared is 5x squared. 5 times what is negative 15x? 5 times negative 3x is negative 15x. And 5 times what is negative 90? Negative 18. So now that I've factored out the 5, I care about this x squared minus 3x minus 18 is equal to 0. So now I'm going to factor using the zero product principle. Specifically, a is equal to 1. I don't want to work. I love it when I don't have to work. So now I figure out the winning team that multiplies to c, negative 18, and adds to b, negative 3. Pause the video if you want to do this on your own. Otherwise, I'm giving the answer in 5, 4, 3, 2, 1. Okay, so if it multiplies to negative 18, it has to be a positive-negative combination. In particular, that positive-negative combination, what does that add to negative 3 tell me? The negative has to be stronger than the positive. So if it's a strong negative and a weak positive, that combination needs to be positive 3, negative 6. Positive 3 times negative 6 is negative 18. Positive 3 minus 6 is negative 3. So that's why it is what it is. 5 gets factored out, and now we're going to bring out, let me just make that a little bit darker, yeah. So now we've got x plus 3, x minus 6, and that whole thing is equal to 0. Now, we've got a multiplication problem. I love a multiplication problem, especially when the output is equal to 0, because now I can use the zero product principle. I am a huge fan of the zero product principle. So now, big or in the middle. So I've got x plus 3 is equal to 0, or x minus 6 is equal to 0. Let's start with the left side. So if x plus 3 is equal to 0, we're going to subtract 3 from both sides, leaving me with x is equal to 0 minus 3, which is negative 3. X minus 6 is equal to 0. So I'm going to add 6 on both sides. So that means x is equal to positive 6. And those are my two solutions in the solution set. Okay, now that that's out of the way, let's get 5 and 6 in here. X squared minus 9 is equal to 0. Something tells me I should be paying attention on this one. Can I factor something from all the terms and still get whole numbers? No, I see an x squared and I see a constant. You know what this reminds me of? This reminds me of hint number 4. In other words, if I have the difference of two squares, in other words, a subtraction problem of two squares, I can factor them into conjugates. Straighten the tie. I said straighten the tie. There we go. Now you're straightening the tie. I can tell. So now we've got x squared minus 9 is equal to 0. I see x squared. I also see that 9 is a perfect square, so I'm going to factor this into conjugates. So specifically, x squared minus 9 can be broken down already into x plus 3, x minus 3 is equal to 0 because it's the difference of two squares. It's a subtraction problem of two squares. So now break this up into two cases. Either x plus 3 is equal to 0, or x minus 3 is equal to 0. So let's start off with the left side first. So if x plus 3 is equal to 0, that means that we undo that layer of x by subtracting 3 from both sides. So then x is equal to negative 3 is one of the solutions. Go on to the other side. X minus 3 is equal to 0. We can add 3 on both sides. And so x is equal to positive 3 for the solution on the right. Number 6, another version of this. Can you see that this is the difference of two squares? X squared minus 49 is equal to 0. how would I factor x squared minus 49 into conjugates? Well, I get x plus 7, since 49 is 7 squared, or 7 is the square root of 49, times x minus 7 is equal to 0. Now we've factored them into conjugates. We're going to split them into two cases. So now, big OR. So now that we've got x minus 7 is equal to 0, using the zero product principle, or x plus 7 is equal to 0, let's solve for x on both equations. So subtract 7, x is equal to negative 7, or add 7, x is equal to positive 7. And that's the solution set. Factoring, made easy. All right. 7x squared plus 21x minus 70 is equal to 0. Solve for all values of x that make the whole output equal to 0. What should I do? Well, first things first, I can factor something from all three of these terms. In fact, if I factor out that 7, thank goodness I don't have to deal with a not being equal to 1. I like it when a is equal to 1. 7 times x squared is 7x squared. Okay. 7 times what is 21x? 7 times positive 3x is positive 21x. And 7 times what is negative 70? 7 times negative 10 is negative 70, and that's equal to 0. Now, I'm going to take a look at this quadratic trinomial over here, x squared plus 3x minus 10. A is equal to 1, thank goodness. Woo, everybody, woo. Woo. So then, all I need to do is just figure out what multiplies to c, negative 10, and adds to b, positive 3. I don't want to work. I don't want to work. I love it when I don't have to work. Because all I need to do is figure out what two numbers multiply to negative 10 and add to positive 3. What two numbers multiply to negative 10 and add to 3? You've got 5 seconds to pause the screen and do this on your own. 5, 4, 3, 2, 1. Okay, so two numbers that multiply to negative 10. Okay. That means that this combination needs to be some sort of positive times a negative. But if it adds to a positive 3, then that positive-negative combination needs to have a strong positive and a weak negative. So without further ado, that winning combination is negative 2, positive 5. Negative 2 times positive 5 is negative 10. Negative 2 plus 5 is positive 3. That's the winning team. But since a is equal to 1, woo, we just jump right into the binomials. So without further ado, 7 times x minus 2 times x plus 5 is equal to 0. I don't want to work. I don't have to work. I'm happy when I don't want to work. So now I've got x minus 2 factored out. So x plus 2 is equal to 0, or x plus 5, hang on, I messed up over here. X minus 2 is equal to 0, or x plus 5 is equal to 0. So let's solve for the left equation first. If I add 2 on both sides, that means x is equal to 2, or subtract 5 from both sides of the right equation, and I get x is equal to negative 5, and I'm very, very happy. Number 8. Oh, that's gotta hurt. Number 8. 25x squared minus 36 equals 0. Oh, man. Oh, man. Hey, wait a minute. It's a subtraction problem. There's only two terms. Is this the difference of two squares? Yes. Remember that the square root of 25x squared is 5x. And the square root of 36 is 6. So even though it's not x squared minus 36, it's 25x squared minus 36, I can still break this down into conjugates, specifically 5x plus 6 times 5x minus 6 is equal to 0. So then I'm going to break this down into two cases. So then I get 5x plus 6 is equal to 0, or 5x minus 6 is equal to 0. And let's solve for x. So let's look at the left equation. What would I need to do to solve for x here? I'm going to subtract 6 from both sides, leaving me with 5x is equal to negative 6. Then I'm going to divide both sides of the equation by positive 5. And that leaves me with x equals, you can leave this as negative 6 over 5. I personally like a decimal, so you can leave this as negative 6/5 or negative 1.2. Either way, they're the same thing, just pick one. If you're a decimal person, write negative 1.2. If you're a fraction person, negative 6 over 5. Doesn't matter to me. I'm happy. Okay, now let's take a look at the right equation. If I add 6 on both sides, I get 5x equals positive 6. 5x equals positive 6 means I divide both sides by positive 5. And yet again, I can write this as 6/5, or if you're a decimal person like me, x equals 1.2. So either one of these will work. Okay. Now, number 9 and 10 I have to put in there just because. 4x squared plus 18x plus 18 is equal to 0. Okay. Well, can I factor something from all three of these terms? Hopefully it's a 4. No, 4 does not go into all three of these terms. 4 goes into 4, yes. 4 goes into 18 as a decimal, though, 4.5. So I think my only option is to divide all three of these by 2. So here we go. 2 times 2x squared plus 9x plus 9 is equal to 0, because I factored the entire top by 2. Is a equal to 1? Come on, come on. A does not equal to 1. Grr, I'm not happy. I gotta work. I have to go to work. So what does that mean? Well, my A is 2, my B is 9, and my C is 9. So what this means is now I need to use the factoring when A is not equal to 1 method. What multiplies to AC and adds to B? Keep those skills sharp. So A times C, that'd be positive 18, because 2 times 9 is 18. And B is 9 itself. So what two numbers multiply to 18 and add to 9? Well, has to be a positive-positive combination. In particular, 6 times 3. 6 times 3 is 18. 6 plus 3 is 9. That is our winning team. But remember, A is not equal to 1. Grr, everybody, grr. That means that I can't jump into the binomial just yet. I have to split that middle term into that gets split into positive 6x and positive 3x. So now we've got 2x squared plus 6x plus 3x plus 9 is equal to 0. So then I go into the rectangle now. Let me just hold that in place. There we go. Big rectangle. Doesn't have to be that big, but it helps. I'm just going to divide it into 4 pieces. The ax squared goes in the top left. That'd be 2x squared. The tiny square is positive 9. And it doesn't matter which one's which. I'm going to put positive 6x over here and positive 3x over here. Cover up the right column. Can I factor out something from 2x squared and positive 6x? Yes. 2 and 6 both have a factor of 2 in common. I can divide a 2 out, but also an x. So the GCF of 2x squared and 6x is 2x. 2x times what is 2x squared? That'd be x. 2x times what is positive 6x? Positive 3. X times what is 3x? Positive 3. Okay. Now, we put those pieces together, and we get x plus 3. Oops, almost fell off the page. X plus 3 gets factored out times 2x plus 3. And remember, since the goal is to figure out all the values of x that make this whole thing equal to 0, factor it, set it equal to 0, and use the zero product principle. So now we're going to break this up into 2 cases. Either x plus 3 equals 0, or 2x plus 3 is equal to 0. So now we're going to subtract 3 from both sides on the left equation. One of the solutions is x is equal to negative 3. 2x plus 3 is equal to 0, so let's subtract 3 from both sides, getting us 2x is equal to negative 3. Divide both sides by 2, and that gets me x is equal to negative 3 halves, or if you're a decimal person like me, negative 1.5 also works. Now, this is kind of annoying because I had to do this long method and then factor into 2 cases. So I'm looking at the clock. Originally I was going to do 10 problems, but I'm looking at the lesson's going a little bit long. So even though it says problem number, I was going to do a problem number 10 with the same thing. I just want to show you guys, so I'll make this problem number 10, and I'm not going to solve it. But in particular, I just want to show you in this problem. So what if you have something like this? X squared plus 4x plus 10 is equal to 0. Hey, a is equal to 1, so that makes me really, really happy. 2 numbers that multiply to 10 and add to 4. Okay, well, I can't think about it off the top of my head, but luckily I can try. 1 times 10. 1 times 10 is 10. 1 plus 10 is 11. Okay, so that didn't work on the first try. Okay, how about 2 times 5? 2 times 5 is 10. 2 plus 5 is 7. Okay, and then so let's figure out another combination that multiply. I don't think this is going to work. This is all part of the script, by the way, so I don't think I messed up. I don't think this is going to work. So just look at your hints. So the idea is you look at this problem and go, I don't think this is going to work. So remember at the beginning of the lesson when I said there's 5 hints and I left the 5th one blank? That's because I said it before and I'll say it again. We're going to end the school year on something what's called if the problem is too hard to factor. I'll teach you something called the quadratic formula. And that is your cliffhanger into the next unit. The quadratic formula is the end-all, be-all method to solve ax squared plus bx plus c. Okay? Next video. What is the quadratic formula and why is it so useful? Have a good one.